Good morning, student. Welcome to online lecture series of discrete mathematics. So, last lecture we have started our last unit, that is groups and rings, and we have studied the what are the basic properties of the binary operations, that is commutative, associative, right? Close operations. So today we will see the semi groups. So what is this semi groups? When we say that this is a semi group, the given algebraic system is called the semigroup. So let A comma star is called the semigroup if first star is a close operation, second one star is associative. So for a semigroup, we have to satisfy these two properties, that is a close operation and associative, right? So for example, consider A comma star is algebraic system where A is equal to, that is A is a set, is equal to 1, 3, 5, 7, 9, right? Up to this infinity. That is set of all positive integers. And star is a binary operation, means a multiplication. Determine that is A comma star is a semigroup. Here, so this set A containing all positive odd integers, right? This set A containing all positive odd integers. So here we have to satisfy the two property, that is close operation, or you can say closure property. Second one is associative. So for closure property, so operation star, we know the star is a multiplication, is a close operation because multiplication of any two positive odd integers, right? So as per mathematical rule, right, whenever there is a multiplication of two positive odd integers, then this multiplication is always a positive odd integer, right? So means this two integers also belongs to that set, and whatever result of that two integers also belongs to that set, right? So multiplication of two positive odd integers is also odd positive integer number, right? So this satisfy your closure property. Next, associative. For this associative, that is A star B star C is equal to A star B star C. So we know the star is a multiplication operation, right? So whenever you consider any three integers, right? So multiplication of these three integers is equal to same. We consider this 1, 3, 5. So it is 1 star star 3 star C is 1 star 3 star C. So both, that is LHS equal to RSS. The result of this both side, that is LHS and RHS, are same, that is 15. Right? Therefore, we can say that this A comma star is a semigroup. Next, inverse element. So what is this inverse element? Let the A star be an algebraic system with identity element E. Let A be an in element A and element B is said to be inverse of A. If B star A is equal to E, so B is the inverse of A. There are two elements A and B. So when we see that this B is the inverse of A, the B star A is equal to E. So operation between these two elements will get the identity element. So what is this identity element? Identity element means identity elements means what? So suppose X is the element, right? And this star is operation. So whatever operation with this element E, with this X, will get X. So this E is your identity element. For example, 1 into 2, 1 into 2, so what is 2? So this 1 into 2 is 2, so 1 is your identity element. Same, suppose 0 plus 2 will get a 2, right? So we can say for this plus operation, 0 is your identity. Getting what is this identity element? Next, so here, so inverse element, right? So that is whatever operation between the two elements will get identity element. Then you can say that these two are the inverse of each other. So group. So what is this group? The system G comma star is said to be a group if so for this group we have to satisfy these four conditions. First condition is operation star is a close operation, operation star is associative, and third one is there exists an identity element, and fourth, for every A belongs to G there exists an element A inverse belongs to G such that A inverse A is equal to E, or A star A inverse is equal to E. Means here we have to find out there exists an inverse element for this group, right? So for semi group we have to satisfy two properties: close operation, associative operation. And for group we have to satisfy four properties: close, associative, identity, and an inverse element. So determine whether algebraic system, this Q, that is a rational number, is a group where Q is a set of rational numbers and plus is the addition operation. So here we have to find out this is a group. So we have to again we have to satisfy four properties: closure, associative, identity, and inverse. So closure property, the set Q is closed under plus operation since addition of two rational numbers is also a rational number. So addition of two rational numbers, we have when we are considering a two rational number, the addition of these two rational number is always a rational number. So we can say that this Q is a close under this plus operation. Next, associative. So operation plus is associative. We have already proved this. Plus operation is associative operation. That is A plus B plus C is equal to A plus in bracket B plus C. That is all A, B, C are belongs to the rational numbers. Identity element. So when we are considering the rational number 0, right? 0 is belongs to this rational number. So then this element 0 is identity element. Means whenever we add any element to the 0, right, we will get that element. So we can say that 0 is your identity elements, means there exists an identity. Then inverse of every element, that is A belongs to Q, right, is minus A also belongs to Q. So as per we know the what is the rational numbers always contain a positive and a negative numbers. So this whenever there is a plus 1 is there, minus 1 is also there, right? So whenever we perform addition of these two, right, addition of these two, so plus 1 minus 1, so that is equal to 0 is there. So 0 is your identity number. So we can say that so inverse element is exist for the every element for the rational numbers. So for example, there is minus 1 and 1, you will get 0. Minus 2 and plus 2, you get 0. So for every element, there exists an inverse element. So identity element. So we have studied this already. Identity left. So there are left identity and right identity. That is E star X is equal to X. If this identity element at the left positions is called as left identity. If identity element at the right position, then X star is equal to X. It's called as right identity. Right. So next is a monoid. Let A star is a monoid if A star is a semi group and there is an identity element. So let we see the example. n is equal to 0, 1, 2, 3, 4 up to infinity, and plus is addition operation determine this n plus is a monoid. So we have to satisfy three properties. Yes, three properties. So there is closure property, associative property, and identity. Right. So we know the plus operation. Sum of two natural numbers is always a natural number. Right. So this satisfy your closure property. Associative property. So we already know the plus operation is associative, right? So it is a plus b plus c, that is a plus b plus c. So all a plus a comma b comma c belongs to the natural numbers. Identity element. So 0 is identity element present in a n, right? So if that is 0 plus 1 1, 1 plus 0 1, so there exists an identity element. Okay, so we stop here.